Es recording. Ajá. Entonces now, guys, mandatory que right hand side must be 0. Right hand side in any problem is 0. Remember, must be 0 because remember, when you are doing the final table in the comparison, you put plus or minus. That means we have positive or negative. The level of comparison is 0. Okay, nobody can solve it. See, right hand side is not 0. And this is the final, no, because I pay my attention now to factorization that part. You are doing your best to factorization that part. To factorization that part is obvious in this case, you apply factorization by grouping because we have 4 terms, this couple and this couple. And this couple and the first couple and the red one, I can see that the great common factor is x squared. We have 2x plus 5. Y in the blue, the great common factor is obvious as negative 4. Well, actually, we have negative, no? And the great common factor between 8 and 20 is 4. It's logical, right? Now we have 2x plus 5. Let me check it out, see the sign I'm using is okay or no. Negative and positive and negative, negative and positive and negative. Okay, super. Yeah, I'm happy because this factor is the same. Look. Therefore, I factorization one more time outside. The factor 2x plus 5. Factor out. And we have x squared minus 4. And that's it. No, because I can see here a famous difference of a square. So the factorization is, the completed factorization is 2x plus 5, open two parentheses, xx 2 plus or minus, less than 0. And now, this is the beginning. Okay, we start doing this problem now. And closing the box, this new inequality, okay, by the way, algebraically is equivalent to the original that nobody can solve it. However, this is easy. When the right hand side is 0 and the polynomial in the left hand side, you break it down in factors. Therefore, when you decompose in factor, we are ready to start. Okay, now remember, temporary we convert to equation because the equation allow me find the critical value. The critical value is important, is the partition of the odd real number line. So 2x plus 5 equals 0. I continue working with this equation. 2x equals negative 5 divided by 2. X is equal minus 5 over 2. Negative 5 over 2 in decimal to see more clear, at least for me, is 2.5. Put in the calculator or divide by hand. And the other factor is x plus 2 equals 0. X is negative 2. And the last one is minus 2 equals 0. S is positive 2. Okay, summarize critical value CB is x equal negative 2.5, x equal minus 2, and x equal positive 2. And I'm using this critical value to make the partitions of the odd real number line. This is my famous odd real number line. Horizontal line, odd real number line, 0 degree. Okay, let's do it here. Okay, positive infinity, negative infinity, 0 in the middle here. Negative 2.5, I suppose case negative 1, negative 2, negative 3 here. And between negative 3 and negative 2, and the middle is negative 2.5. Partition. And negative 2, partition. And 2, positive. 1, 2. Another partition. Actually, we have in this moment 1, 2, 3, and 4 intervals. Okay, it's totally expecting because we have 3 partitions, and so when you are doing the partition, the ordinary number in 3 parts, actually we have 4 intervals. Now selection arbitrary testing point inside each interval. Well, I select in my paper, I select -3. I like -3. Because -3 or -4 or -5, it doesn't matter. Give me the behavior of this interval. Here is a small interval. This is -2.5, -2. I select -2.4. I select 0. Why not? I like 0 because it's easy to evaluate. And you select 3. 3 or 4 or 5 or 6. Okay, using this testing point, I create my table. My table is TP. I list in the testing point vertical. Here's -3, -2.4, 0, and 3. And in the column, I put the factors. Doesn't matter. The order is not important. X plus 5, is this factor, right? This factor and this factor in the region, huh? X plus 2, why not? X minus 2, and a total. This is my table. Entonces, one by one, carefully, you evaluate in each factors the corresponding testing point. I would like to work it row by row. The -3 is obvious is negative. Why? Because -3 times 2 is -6. And -6 plus 5 is -1. But I don't care the value, I care the sign only. It's negative here, it's negative here. And 3 negative, give me negative. Remember, the total I am closing the circle because it's important information I need to understand. This is partial. It's not important. -2.4 here, multiplication by 2 is -4.8 plus 5 is positive something. Negative, because it's -2.4 is bigger than 2, it's negative, entonces double negative here, -2.4, and -2 is like a -4 point something, 4.4. It's -2, negative, positive. 0 is positive because it's just 5. 0 is 2, que es positive. And 0 here is negative. 1 negative is negative. Positive 3 is positive, is positive, positive, is positive. Okay, we come back to the original problem. Not exactly the original problem, this inequality guy enclosed in the box is important. And less than 0 is equivalent to say, synonymous to say negative. The solution is when the column of the total is negative. This interval and this interval. Okay. Now I highlight this interval. It's -3 is this interval. Okay. Of course, this interval is extending from -infinity to the critical value, que is -2.5. No? Remember, -3 was arbitrary point que I select to understand the behavior of this interval. Pass the test, okay. However, -3 or -4 or -5, but what the total interval is from -infinity to stop, and the critical value associated with this is 2.5. And one more passing the test, this guy, okay, is from this to this, and the rest no. This is small interval, no, and the other is positive, no. The final answer in this problem is answer. From -infinity, comma, 2.5, or either way, -5 or 2, in decimal or in fraction, doesn't matter. union, because you have two pieces. The second piece is from -2 to +2. Boom. Final answer. Any question, guys? Do you understand very well this problem? Okay. Yes. In the test, in the reading test, I want to see the student, I don't know why, don't respect this method. I know that there are another method, but it's complicated because you have 3 factors. So another method is separate this in 3 inequality. But there are 8 combinations, no? Because it's plus, 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 minus. No. This is the efficiency way. In this method, I see one big part, que es algebra. That part is algebra. Okay, you factorization, you convert to equation, you determine the critical. This is algebra. We have another part here, que es graphic, que es using the critical value, you are doing the partition, and selection, the testing point. And finally, the table. In the table part, you testing the testing point and maybe pass or fail. And yeah, finally, you come back again to the graphic part and you select using, arbitrary color, highlight the interval solution and write the answer in interval notation, always in interval notation. No, not always, but frequently in the test, I like this way. Another possibility to write this answer in set builder notation is that part is x less than -5/2 or x in between -2 and +2. Okay. And the formal way to set builder notation is x here. Okay, open the curly bracket. This is equivalent to this, but I prefer this way. Interval notation. Any question, guy? No? Do you understand very, very, very well? So now, today we practice a lot of problems of this. Okay? No problema. Everyone understand very well? Yes or no? Answer me.
Yes.
Okay. May I erase the board?
Yes.
Okay. So now I want to discussing the same thing, polynomial inequality, but I want to explain a more detailed special case. Special case. Okay, you need to be aware. Que frequently happen. Special case. I explained something last class. Okay, when the factor is, you have factors, several factors, and when the factor is, the exponent is even, you can delete. I explained something, but no, it's complete explanation. We need more clear idea. Look, because the reason is clear because it's a factor que is raised to the second power is positive, no? Entonces, the positive, remember, do not participate in the analysis of the inequality. But let me start for the elementary example. Look, suppose you have this example. 3x minus 4 squared greater than or equal to 0. Wow. The right-hand side is already 0. Good. Somebody do me a favor to factorization this expression. Okay, nice. Number or expression, doesn't matter, right? Okay, entonces now, remember the key idea. The key idea is the positive term we can delete, right? Because do not participate in the game. The game participate the negative because negative times negative times negative is negative, or negative times negative is equal positive, no? So the decision of the inequality is made by the negative. The positive participate, but not too much. Entonces now, what do you think about these 3? We can delete or no? These 3. Yes or no? We can delete 3. Yes or no? Answer me. No idea. We can delete these 3. Or 3 or any number, 5 or 20 or 1000. We can delete or no? No idea. Nobody know?
Yes. Yes.
Yes. You. Why? Why? What is the reason I can delete? What is the principle? Allow me delete these 3. Because 3 is positive. Okay? That doesn't matter. Another point of view. Another point of view. Bueno, professor, okay, you divide by 3. You divide by 3. 3 divided by 3 is 1. X minus 4 square greater than or equal to 0. Pero no, not necessarily doing this. No. You apply the principle. Any positive number, we can delete. That's it. End the story. Oh, entonces, bueno, professor, I understand. However, what's going on if it's negative I? We can delete or no? Suppose another example. Hypothetically. Negative 3 or negative whatever, x minus 4 squared. Greater than or equal to 0. We can delete this negative 3 or no? We can delete or no? Negative 3. Can delete negative 3. Yes or no? Come on.
No.
No. No, you are right, no. But we are doing something, don't frustrate for the negative, because you multiply the entire inequality, you multiply multiplication by negative 1. Entonces, si negative 1 and negative 3 together is positive 3. You multiply, bueno, yeah, I did the multiplication one time, no? Entonces, x minus 4 squared and negative 1 times 0 is 0, no? But what happened with this sign? Stay the same or is reversed? Stay the same or is reversed? This is an important principle. In any inequality, when you multiply or divide by a negative number, you have to reverse it, the inequality sign. Okay, so this inequality and this inequality are equivalent, 100%. Now I am ready to delete these 3 or no? Yes or no?
Yes.
Absolutely. So now, guys, when you see numerical value, you can delete. Si es positive, delete directly. Si es negative, well, you can delete and reverse it, the sign of the inequality, right? But let me finish this problem. Okay, I don't finish. Let me finish this problem. Okay, I don't finish. Entonces, professor, well, I deleted 3. Okay, super. However, I have here in that moment one factor que the exponent is even, and you say, professor, que we can delete. What is the principle behind this? Well, you know very well que x minus 4, o sea, y equal x minus 4 square, es parábola. Es a square function in 1, 2, 3, and 4. It's a parabola que open like that. Of course, touch the x-axis. And you see clear que this is always positive. It's always positive. And is only 0 at x equal 4. So this statement is super true always. It's true. Anytime. That means that the solution of this is all real number from negative infinity to positive infinity. Do you see that or no? That this parabola is always positive or or at x equal 4 is 0. It's that point. And satisfy perfectly because our inequality is greater than or equal to 0. So at x equal 4, plugging in 4 minus 4 is 0. 0 squared is 0. Okay, no problem. It's true. And another number bigger than 4 or less than 4, like a 5, like a 6, or like a 3, or like a 2, is positive. Therefore, satisfy perfectly this inequality. Do you understand this? Okay, entonces now we can totally delete. However, I want to change something now. Look, I want to change one small change. Look, suppose another problem, que es 3 paréntesis x minus 4 squared greater than 0. Okay, professor, I understand very well que we can delete this 3. Boom. And exactly the same happen? No. Why no? Because at x equal 4, you know, plugging in here, 4 minus 4 squared is 0, and 0 is not greater than 0. It's a contradiction. Entonces I don't understand anything. Delete or no delete? Well, delete or partial delete. This is partial delete. Partial delete. So in this case, okay, in this case, if you want, you delete, pero you introduce one restriction que x no 4. Because in 4, I know what happened, que es 0. It's 0. So what is the solution of this inequality, professor? Well, the solution of this is all real number, exactly like that, except 4. Because in 4 is 0. So the solution is in self-building notation, x such that x not 4, or equivalent to say from negative infinity, comma 4, pero paréntesis, no incluye 4, union 4, comma infinity. Entonces, using that principle, que es totally delete or partial delete. This is totally delete. Totally delete. So delete what? Delete the factor que contain even exponent. No, the factor que contain odd exponent never delete. But the factor que contain even exponent, we can totally delete when our inequality include equal sign. And partial delete when our inequality do not contain equal sign. No, this is missing. This equal sign is missing. Okay, let's see example. And you mechanically, you are doing this. Not necessarily analyze one by one, theoretical. No. Suppose this. X minus 5 multiply x minus 4 squared greater than or equal to 0. So I make it easy because I want to focus in the central idea okay, I want to discuss it now. I manipulate the inequality, I create right hand side 0, I do the factorization of the polynomial on the left hand side, you get that. When you are doing that, you see, wow, one factor, que es x minus 5, the exponent is 1, que es odd number, stay alive, and another factor is 2, que es even. And you say, professor, que cuando es equal, totally delete. So this inequality, guys, is equivalent x minus 5 greater than or equal to 0. And you mentally delete this guy, totally, because it's equal. Entonces solving this is super easy. You solve for x greater than or equal to 5. Suppose that I want to express an interval notation is, this is my real number line. This is 0, this is 5, is greater than, entonces that direction. Okay, I include 5, of course, bracket here, and the notation and the interval notation is This is equivalent to say bracket phi, comma, infinity. Everyone follow me in this example? Let me call example 1. Because actually, the other example we were doing before is like an introduction to the theoretical part. But this is the first example to illustrate one example. No? In this case, I apply totally delete. Example 2 now. Suppose x minus 3 times x minus 4 squared greater than 0. This is similar. It's similar, no? Oh, no, it's different because in this case, partial delete. How do you know it's partial? Well, it's partial delete because you have no equal here. Equal, totally delete. So this is equivalent. Be careful with this. Be careful. Partial delete means, okay, you copy the factors. Okay, we have exponent odd. Stay the same. But you include restriction and no 4. And no 4. Because I know that 4 minus 4 is 0. Entonces 0 times something is 0 y 0 is not greater. Now 0 is a contradiction. So you delete the factor, pero you include a restriction. To understand this, it's a compound inequality, no? Connected by AND. You have 0 here, 1, 2, 3, 4. This is, you solving this part, okay, it's easy, it's x greater than 3. And 4, we have a hole. Look at that, we have a hole. We have a hole here. We have here this piece and this piece. And of course, do not include 3 inside the solution. You put the parentheses, no bracket, because my inequality is a strict inequality. Do not consider equal sign. And when this situation happens, never we have the solution, the endpoint. No. So what's the answer? In this case, the answer is parenthesis 3, 4, parenthesis also, because we have parenthesis here and parenthesis here, union 4, infinity. Okay, partial delete. No included this. Okay, another example. You understand or no?
Yes.
Very, very important to be aware for this situation. When it's positive, in this case, a parabola, no? The parabola is always positive because the exponent is even, but be careful because if our inequality is no strict, inequality, no equal, entonces you introduce the restriction. Another example, suppose this, x minus 5, multiplication, x minus 4 again, square less than 0. Okay, again, it's a typical example of the partial delete because I can see one factor can contain exponent even, but our inequality no is equation, no have no equal sign, it's a strict inequality. Okay, therefore this is equivalent to say x minus 5, this stays the same, and x not 4. As always, when you have compound inequality, you finish the solution for the compound inequality and graphically. This is 0, 1, 2, 3, 4, and 5. Okay, according to this part, this is x less than 5. And x less than 5 is to the left in that direction. However, I saw, okay, 4, we have a hole. We have a hole, according to this restriction, no? Entonces, paréntesis, paréntesis, paréntesis. The solution is then from negative infinity, comma 4, union 4,5. Super good?
Yes, yes.
Okay, one more case, important, extremely important. This is, we are talking about a special case. In the regular case, when everything is odd exponent, no problem, you consider everything and you finish in the table, no? But in this case, you can simplify, delete some factors. Suppose this example, suppose x squared plus 4 times x minus 5, less than 0. Now, this factor, look, it's important you see the differences in between this factor, look, and this factor. Because this factor, graphically, I understand que es parábola. Pero esa parábola que en 1, 2, 3, 4 open up and touch the x-axis. However, this no. This is different. This is x squared plus 4. In this case, the 4 is completely, you know, it's a vertical shift. In this case, horizontal, no? Entonces es 1, 2, 3, 4. The parabola look like that. That the vertex of this parabola is 4,0. The vertex of this parabola is 0,4. Entonces es obvio que this parabola is always above the x-axis. So this term is positive. Always is positive. And you can delete totally. It doesn't matter regardless que es less than. So regardless que es less than. No less than. However, I can delete when it is x squared plus 4. Okay. So immediately I realize that this is equivalent to x minus 5 less than 0. Therefore, x is less than 5. Therefore, the answer is from negative infinity, 5 parentheses. Do you understand the difference between this guy and this guy? Clear or no?
It's clear.
Ajá. Entonces, okay. In the several examples we're doing today, I intentionally included this kind of factor or this kind of factor. Okay, and you realize you totally delete or partially delete. Okay. Let's move on now to another topic que es similar. Is the rational inequality. Because we are studying polynomial, polynomial for a moment, no. Polynomial. Let's move to the rational inequality, que es similar. It's exactly the same. Rational inequality is the same procedure. It's the same. Bueno, no 100% equivalent, pero es similar. Es similar. Some detail, some specific detail. Okay, entonces now to simplify the thing, I somebody do the job for me, que manipulate the inequality and create the right-hand side 0 and also factorization the top and the bottom. Remember, rational function is the division to polynomial. So in the top we have that, in the bottom we have that. Okay, and this is graded down or equal 0. Okay, so we are doing similar strategy. Similar. Look, number one, you determine, well, actually, some job is doing right-hand side 0. Nice, I love you that. Some people forgot that. After you see example, intentionally, I giving you the problem in a different way, and you don't know how you start. And The principle is this. You need to create always, anytime. Right-hand side must be 0. Okay, now we have fraction, and you determine the critical value. What is the critical value? Critical value in the top and critical value in the bottom. Critical value in the top is the polynomial in the top equals 0. Critical value in the bottom is polynomial in the bottom equals 0. Plus 1 here, minus 1 here. Doesn't matter the order, no? Es multiplication. Es obvio que x0 and x2. Critical value. And it's obvio que es 1 and negative 1. Critical value. In this case, we have 4 critical value. Okay, no problem. This is don't intimidate me. Okay, 4. Because we are doing 4 partitions, and that's it. This is my line. Remember, the solution of this inequality contains one part is algebra and one part is graphically. And the part graphical is now here. This is negative infinity, positive infinity, sorry, negative infinity. And the partition is 0, look, 0, 2, 1, 2, 1 positive and 1 negative. Okay, and we have how many? 4 partitions indicate us. We have 1, 2, 3, 4, and 5 interval. And for the 5 interval, I need to select 1 testing point. In my paper, I select negative 2. I select here negative 1/2, maybe negative 1/2. Here positive 1/2, and here 1.5, and here 3, or 4, or 5, or 6, doesn't matter. 5 testing. Ya listing the testing in my table. TP. Negative 2. Negative 1/2. Positive 1/2. 1.5. And 3. You say es long, pero es easy. No big deal. Entonces ahí listen the factors que participen en our inequality, que es x, doesn't matter the order, x minus 2, x minus 1, x plus 1, and they attach 1 extra column, que es in which I summarize the signs. Super easy. And little by little, you fill out this table under the signs. I don't care the value, I care the sign. Well, es obvio que this is negative, positive. Because it's x is exactly the same the testing point. No arithmetic operation, no subtraction, no addition. That is the reason I fill out this. Pero no. The original way is doing row by row. So negative 2 is negative, it's obvious, right? Because negative 2 and negative 2 together is negative 4. And negative 2 and negative 1 is negative 3, is negative. And negative 2 plus 1 is negative 1, is negative. We have 1, 2, 3, 4 negative is positive. Okay? Because somehow negative times negative divided by negative times negative is obvious que es positive, divided by positive que es positive. Makes sense, right? Mechanically, we are doing it that way. We count. How many negative we have? 4. It's even. It's negative. It's positive, sorry. Si es odd, negative, and the gain is negative. Si es even, it's positive. Not necessary to do step by step now. Okay. So now in the second row, we have negative. We have negative. We have negative. And here is positive. Why positive? Because negative 1/2 plus 1 is positive 1/2. So we have how many negative? 1, 2, 3 is negative. Positive half. Bueno, es obvio que es positive, es negative here, es negative here, y es positive here. How many negative to negative? Es positive. 1.5 is positive and negative, it's obvious. 1.5 minus 2 is negative 0.5. Here is positive because it's bigger than 1, and here is positive. We have only one negative and negative. You see the control of this column is given by amount of negative. The positive do not participate almost in this game. And finally, the last column is plus, 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 and the answer is plus. When we come back to the beginning say greater than or equal to 0 is synonymous to say the positive guy is the true. Entonces the positive guy is the true here, and here. 3 intervals make true, and 2 intervals false. Entonces, what interval is true? Este con el negative 2 pass the test. Que es this interval. One more half.
Hello.
Half. Hello. Do you hear me or no?
Sorry, I'm just a little confused.
Go ahead.
On how you got plus.
Okay. Don't worry, I explain now. Look. Suppose que I select the first row. Y I evaluate the first testing point que es negative 2. So we are working this in any expression. This. And you just plugging in. Look, here. Negative 2 plugging in here is negative 2 minus 2 is negative 4. And that idea que negative 4. Oh, okay, you put negative here. You put negative here. So you evaluate, mister, any testing point in each expression. You put in the table only the sign, not the value. Actually, I know que es negative 4. Pero no, I don't care this. It's only... Okay, got it?
Yeah, okay, I get it. Thank you.
Okay, entonces let's continue. Okay, entonces now I discover que the solution is this interval in which the testing point que I selected was negative 2 is true, and 1/2 is also true, and 3 is also true. That's it? No. Why not? Because I need to analyze what's going on in the end point, so the point que connecting this. So now I come back at the beginning. Yeah, I can see that our inequality, look at that, is a combination inequality greater than an equation equal sign. Therefore, this is 0 equal to 0 when the top is 0. And the top is 0 in this and this. That means that in 0 y en 2, we have bracket. However, in 1 and negative 1, no. Es 0 denominator que son defined. No inside the solution. Paréntesis. In conclusion, guys. In conclusion. When you have inequality, rational inequality, this is the only sophisticated and different detail with respect to the polynomial. And polynomial was easy because in polynomial, si es equal, you put a bracket, and no equal, you put the parenthesis. And rational, when there's equal, you put a bracket, but in the 0 of the numerator top, and never in the 0 of the denominator. That's it. It's a principle. Now, what's my final answer then? My final answer is then from negative infinity, comma, negative 1. Be careful because the student confused in this moment and putting the solution the testing. No, the testing is completely arbitrary, guy, que represent the behavior in this interval. Que maybe is negative 2, negative 3, negative 4, negative whatever. However, the interval is extending to stop in the critical value, que es negative 1. And this is paréntesis. because do not include a negative one. Union. Actually, we have three pieces. Bracket 0,1. Parenthesis. Union. Bracket 2, comma infinity. End the story. This is my beautiful final answer. Any question? Any question? Yes or no? Got it?
No question.
No question. Okay. Okay, let me know if I can erase the board to complicate a little bit your life now.
Yes.
Okay, go ahead. Okay, this is a classical example, look, of the rational. 1 over x minus 2 less than or equal 2 over 3x minus 9. Wow, I have no idea how it started. Okay, I have no idea. And some people say, no. I apply cross multiply, maybe. And you convert the proportion, that proportion in one equation in only one line. This is wrong, completely wrong. Why no? It's impossible to do it that way. Because you apply cross multiplication. What sign you apply? This sign or this sign? Remember, when you multiply, you don't know what's the solution. Maybe the solution is positive or negative or a combination both. Then I don't know if I put this sign or this sign. I don't know if it stays the same when it's positive or reverse it when it's negative, no? So this is impossible to do it that way. Some people consider both possibility. This is possible, however, it's long and stupid. In my opinion, the best way is, as always, I repeat one more time this idea. Remember the principle. Right-hand side must be 0. Therefore, I move 1 over x minus 2 minus 2 over 3x minus 9 less than or equal to 0. This is important, super important. In any problem, you must create that. So far, it's okay? Now, what should I do? Well. In this case, it's obvious, okay, this is, I know, enclosed in the box, because remember the previous example, we have no two fractions separated by plus or minus. No, we have only one condensing fraction can include one numerator, not two numerators. This is crazy. And two denominators. No. So I need to do something in order to condensing these two fractions in only one. Okay, but this is super easy algebra. First of all, I realize in this denominator, I have a greater common factor, that is 3. This is important because in this step, I need to find least common denominator. And to have to find least common denominator, we need factorization, any factor, any algebraic expression. The least common denominator es obvio, que es x minus 2 times x minus 3, and don't forget 3 also, no? This is the least common denominator. I copy then one long line, and the long line, I copy the down and the bottom, the LCD. Okay. And the top, one on the top, I don't see. I need to see. Remember, you divide LCD by denominator 1, multiplied by corresponding numerator. This is numerator 1 and the first fraction. This is denominator 1. Likewise, in the second, we have numerator 2, and here is denominator 2. Entonces, this is the formula, no? LCD divided by denominator 2, multiplication by numerator 2, no? Entonces, when you divide this guy divided by this, es obvio que x minus 2 es cancel. And stay alive only 3 times x minus 3. Time numerator 1, que in this case is 1, entonces es invisible. Actually, the thing is 3 times x minus 3. Everyone follow me so far? Minus, I don't finish. I did the first fraction. You divide mentally in your mind 3, que es LCD, 3x minus 2, x minus 3, divided by x minus 3, minus 2, sorry. This is cancel and stay only 3 times x minus 3 times 1, because numerator 1 is 1, it's a coincidence. Si es no 1, es another number or another expression, you multiply by the corresponding, no, but in this case, likewise, in the second part, que es this, you divide again the LCD divided by the denominator 2, que es 3x minus 3, es obvio que x minus 3 cancel and 3 also cancel, and stay alive only x minus 2 times 2. Entonces 2 times x minus 2. Entonces 2 x minus 2, ¿no? And bring down less than or equal 0. Everyone follow me in this algebra? This is intermediate algebra. This is not complicated. I explain it there because maybe somebody's forgot a little bit, but this is the basic intermediate algebra. Okay, now what should I do? I finish. No. I distribute here and combine later. Distribute here because I want to remove the parentheses. 3x minus 9 minus 2x plus 4 divided by 3x minus 2 x minus 3 less than or equal to 0. Well, ready to combine later. 3x minus 2x is 1x. And negative 9 and positive 4 and negative 5. Divided by 3x minus 2 x minus 3 less than or equal to 0. Everyone follow me so far? Was confusing, complicated? This is the manipulation that I should do. Okay, nobody can solve in this inequality like I write at the beginning. It's crazy, and it's more elegant. This is similar to the previous example, no? This is very, very similar to the previous example. I have a question. Do you follow me? Yes or no?
I have a question.
Go ahead.
Why did you multiply by 2 when you had x minus 2 at the end?
Well, it's a formula, miss. It's a formula, but I can...
Oh, wait. I see.
It's a formula. Look at the formula. The formula numerator 2 is 2, no? Do you see the formula?
Yeah.
Okay. Suppose a fraction. Elementary school. 2 over 5 plus 3 over 6. Entonces, LCD es 30. Because it's 6 and 5 together, no? 30 divided by 30 divided by 5 is 6. And 6 times 2 is 12. Likewise, 30 divided by 6 times 3, que es corresponde numerator, dice 15, no? Do you remember that or no?
Yes.
Exactly like that we are doing, but using no numerical values, algebra expression. Super good?
Yes, thank you.
Excellent. Now I have a question. We can delete these 3 or no?
Yes. Positive.
Yeah, because it's positive, she said. So I can delete these 3. Okay, entonces this is our nice, elegant, super fantastic inequality que I want to start the analysis. I know it's too long, but this is not the point. It's easy. Okay, now in this moment, I am ready to find critical value, make a partitions, select testing point, and create my table to simplification of the thing. Okay. Okay, let me read that part because this is elementary algebra. Even that part. Even that part. We focus in the important part. Okay, critical value. Critical value is the zero of the numerator and denominator. X minus 5 equals 0, F5. Es obvio que 5. We are doing partition 5. X minus 2 equals 0, X equal 2. Another partition and 2. X minus 3 equals 0, another partition and 3. Wow, easy. 2, 3, 5. I create my all real number line. I suppose that this guy is 0, 1, 2, 3, 4, and 5. Yeah, I select. In this interval, one guy, arbitrary, guys. Another here, another here, another here. Completely arbitrary. There's one representative of the interval. In my paper, I select, I don't know why, no specific reason, I select one. Obviously, I select here 2.5. Here I select 4, and here I select 6. This is my testing point. So I'm ready to create the table. 1, 2.5, 4, and 6. The factor involved in my problem is x minus 5, x minus 2, x minus 3, and total. Okay, this is my table. Can you help me for solving this inequality? Okay, this is negative because negative 1 minus 5 negative 4. This is negative also because 1 minus 2 is negative 1. And this is negative also because 1 minus 3 is negative 2. And 3 negative is negative. 2.5 minus 5 is negative. 2.5 minus 2 is positive. And 2.5 minus 3 is negative. We have 2 negative is positive. 4 minus 5 is negative. 4 minus 2 is positive. 4 minus 3 is positive. We have only one negative is negative. 6 is positive. Positive, positive, and positive. Okay, we have the sign. We come back at the, remember, not the beginning. No. We come back to the inequality que yo enclose in the box after the simplification, after the algebra part. And you see less than or equal to 0, que es sinónimo to say the good guy, the solution is negative. So the true value in this logic table is the negative guy. So this is true and this is true, otherwise it's false. And it corresponds with the testing point 1, que is associated with that interval. And 4, que es this interval. Okay, include the endpoint? Yes, include the endpoint, but what endpoint? The 5, only 5. 5 is the 0 of the numerator is 0. 0 of the denominator is illegal. Therefore, you consider a bracket here, parenthesis, parenthesis. My final answer then is, is negative infinity, comma 2. Union, parenthesis 3,5. And it's a bracket. This is my fantastic final answer. Any question? Do you understand very well everything or no? Confused and complicated? Confusing? Any problem have one important part of the algebra, in which suppose you working in the rational, you need to do something in order to express it, my problem, in one compact rational function in factory form. Nice. And well, the right hand side maybe is right hand side is 0, less than or greater than. This is the important thing. Similar idea in polynomial, because in polynomial you manipulate, but in polynomial we have no denominator. We have only one polynomial. Suppose only the top part, only the top, right? Okay, ready. I bring several examples, miscellaneous, and thus we practice everything, polynomial, rational, and the new concept of the totally delete or partial delete. Okay, suppose this example, que es interesting. X to the fourth power less than 9 x to the second power. What should I do? Any help? What should I do? Help me, guy. Professor, you should do something like that. Come on, how you manipulate this inequality? Nobody can solve it. This inequality in that way. You need to do something. What should I do? Help me, guys.
Move the line.
Exactly. Why? What is the reason? She said,
Right hand side has 0.
Excellent. She said, que you move 9x squared to the left because I need to guarantee somehow que right hand side must be 0. In this case, it's strict inequality less than, no equal. Okay, no problem, I understand. What should I do after that? What should I do after that?
Factorization.
Exactly, factorization. In this case, the great common factor is, remember the order in the factorization, exactly the same we're doing in intermediate algebra. The complete factorization of the polynomial, you are doing, first of all, greatest common factor. After that, binomial, trinomial, grouping, etc. However, in this case, the greatest common factor is x squared. We have x squared minus 9. Here I can see, wow, this is the difference of square, and the factorization is x 3 and negative 3, positive 3 and negative 3, doesn't matter the order. And this is my important, super important inequality. That is the reason I enclose on the box, because it's important. And you can delete something or no. Partial delete, totally delete.
Partial delete the x squared.
Entonces now how you partial, when you delete partial, you copy the rest, que es no square, and you introduce and something, no? Entonces I copy. She said que es partial delete. I agree with her. X plus 3, x minus 3, que este part que no incluye x squared, because I can delete this, pero delete partial, less than 0. And to delete partial is you put an x, no, 0. Because si x is 0, 0 squared is 0, 0 times anything is 0, and 0 no is less than 0. So you exclude 0. This is typical partial delete. Do you understand this? Now you're solving this inequality. So you're solving that part under the consideration that 0 never is inside the solution. Okay? Do you follow me?
Yes.
Entonces I copy that part separately. Yeah, it's solving exactly the same we're doing before. You convert these two equations. Because the equation allow me to find the critical value. X plus 3 equals 0. X equals minus 3. And x minus 3 equals 0. X equals positive 3. And this is my critical value. Okay, using to make the partition of the all real number line. And this consideration I include in the last moment, not now. Which I focus it to solving this part. Remember, the solution for the compound inequality is a two inequality or three inequality. Que is connecting by and or by or. In this case, no. In this case, it's always by and. You solve it separately, one by one. And finally, we connect. Connecting means intersection. In this case, intersection because it's and. Okay, so I make a partition of the all real number line. I am focusing in this inequality, guys. This. Temporary, I forgot that part. This is infinity. This is negative infinity. Partition in 3 and negative 3. Suppose 3 here. Suppose negative 3 here. You select, we have 3 intervals. This interval, and this interval. And you select inside each interval one testing point. I never select 0 because 0 is confusing. 0 is, I don't know exactly what's going on in 0. Entonces I select negative 4 maybe. I select negative 1 maybe. Or positive 1. Positive 1 is good. I select positive 4. Just in case to make sure, because something will happen in 0, is the restriction, something, I select negative 1. But in my opinion, not necessary. But let's do it, because I am not sure. I need to make sure it's the same behavior. No, I don't know. Okay, entonces now I create my table, TP. Get 4. Negative 1. 1. And 4. And the factor is x plus 3, x minus 3, and total. Only 2 factors. Okay, this guy is negative. This guy is negative. Entonces positive. This guy is positive. This guy is negative. And negative. This is positive. This is negative. This is negative again. And 4 is positive. Positive, positive. And you see, get the same. This and this is no coincidence. That means that the behavior, so I highlight that part. So it's expecting. It's expecting. But the problem is that we have a hole in 0. Here. In 0 we have a hole. Okay, therefore is parenthesis, 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 and parenthesis. And the answer is, so some students see this idea at the beginning, not necessarily including negative 1 and 1, because it's the same interval. Pero just in case I did to verify you, pero okay. Entonces, the answer is, the answer is negative 3, 0, no include 0, union 0,3. Good. Good or not good?
Good.
Let's move it on to another example, and you help me to understand it. Okay, look. I want to erase the board. I can? May I? Yes or no? Yes or no?
Yes.
Okay. Okay, suppose this problem. 9 minus 3x over x squared less than or equal to 0. Solve this. What should I do, guys? I'm confusing. What should I do? I can delete something or no? I can delete something or no?
The x squared.
And totally delete or partial delete?
Totally.
Exactly. Entonces, she say que this inequality que is given at the beginning to confuse us is equivalent to say 9 minus 3x less than or equal to 0. Yes or no? I delete this guy. Totally delete. Totally delete. Do you see that or no? Everyone saw that? Entonces, this inequality is linear. Is you solving exactly the same we are doing in the intermediate algebra. Not necessarily do partition, testing point. No. This is super easy, elementary. I move, for example, minus 3x less than or equal negative 9. I move 9 to the other side, divided by negative 3 both sides. X is greater than or equal because I reverse this when you are divided by negative number or multiplied by negative number 3. And that's it. And the answer is, you want to express the answer in interval notation is bracket 3 comma infinity. Very, very good or no? Very, very good or no?
Good.
Well, I have another similar. Look, another similar. Suppose 4 minus 2x divided by x squared. In this case is greater than or equal to 0. What should I do? What should I do?
Take out that square completely.
Similar. I realize x squared is possible doing, delete, and it's equivalent to say 4 minus 2x greater than or equal to 0. Entonces, solving this is super easy. Entonces, the answer is from negative infinity, comma 2. Bracket. Another students say, well, professor, you can solve it different, like that. Suppose 4 greater than 2x. Say you move 2x to the right hand side, no? Divided by 2. 4 divided by 2 is 2, greater than x. And now, sorry, equal here. And now you reverse it. So when you interchange, you put x here and you put a 2 here, you have to reverse it one more time. There are two reasons in which you reverse the sign in the inequality. When you divide or multiply by a negative number or when you interchange. It's obvious, right? It's obvious, right?
Yes.
What way you prefer, divide or interchange? Either way, no? Or what do you prefer? No, I don't know. Answer me. What do you prefer? No preference.
Dividing.
Dividing. Me too. Me too. I don't know why in my brain, mentally, it's better this way. Okay, suppose this example. X minus 3 divided by x squared plus 1. Show me this. What should I do? What should I do?
Partially delete.
Partial or totally? What is the idea that you delete? You know when it's partial or when. What is the glue that give me information? Si it's partial or totally? Totally partial. When you have one factor que contain a square, so this kind, no, this kind of the format que is x minus something square or x plus something square or x square plus something or x square plus 100. This is a good candidate to delete, no? Chan, delete. Now, how do you know que es totally or partial? Bueno, the partial is, totally is when it's less than or equal or greater, o sea, include equal sign. Because it's the potential 0. And here, no, fail, because you get contradiction. Entonces, in this, when it's, the clue is partial delete when you have no equal sign. Yes, totally delete when you have equal sign. In this example, you have equal sign. Entonces, partial or totally? Totally. Now, this is equivalent. X minus 3 less than or equal to 0. Because the reason is because this guy is positive always. And you know what happened with the positive is completely delete. This is behave like a one number, 3, 20. There's no participate in the change of sign of the game. Therefore, I delete in my mind, stupid guy. Now solving this, you focus on this is easy, is x, is x less than or equal to 3. Is from negative infinity, comma, 3 bracket. Is the answer. Good or not good? Okay, let me complicate a little bit your life. Suppose this. X to the 4th power divided by x to the 2nd power plus 9 greater than or equal to 0. What do you think about it? This is confusing. This is to confuse you. I create to confuse you. This example. Okay, both expression, the expression in the top is always positive. Except in 0, que es 0. Pero no problem because in this case we have equal to 0. And the expression in the bottom is always positive. In this case, never is 0. Remember, these guys, you are doing the graph of the x to the 4th power. And you are doing the graph of the x squared plus 9 to see more clear. Because one graph is one picture, and one picture you understand much better than 1,000 words. Suppose x to the 4th power is a power function like that. Similar to the parabola. A little bit flat in here, x to the 4th power. And x to the 2nd plus 9 is, you know, this is 9. It's a parabola like that. in which the vector. This is always positive because it's above the x-axis. And this is always positive because it's above the x-axis except 0. Pero our inequality includes equal sign. What do you think then? This expression, guys, always is positive or 0. Therefore, the answer is directly without do anything, using the common sense and imagination. Orion. Do you understand this one?
Yes.
Yes. Aha, but I am bad guy. Suppose I want to complicate your life. You put in the test, something like that, x to the 4th power divided by x to the 2nd power plus 9. Exactly the same, but I change something. I change, que es less than. What do you think about this inequality? Okay, by the way, it's totally the negation of the previous. It's completely opposite. It's completely power. Because the other is positive or 0 included, but this is negative. My question is now, we focus. When, at what value of the x, this expression is negative? Remember, less than 0 is equivalent to say to be negative, no? Okay. What do you think? Totally lost? Look at the graph. The expression and the I want to investigate this expression divided by this expression is negative. Negative is that part. Negative. Negative. Opinion. What is your opinion? Opinion. No doing any algebra. No. This is a special case only common sense. Nobody have idea? Okay. I prove in the previous example that this expression is always positive. The word que matching perfectly with this idea is que never this expression is negative. Entonces no solution. Do you understand this or no? Do you understand this or no?
Yes.
Bueno, entonces eso no solution. Because the expression que I want to manipulate, I want to analyze both x to the 4th power, look at that, and x squared plus 9, look at that, it's always positive. And positive divided by positive is positive. Entonces, this inequality is stupid. You put this guy, que always is positive, is negative. No, it's never happened that. Okay, suppose to complicate more your life, I copy exactly the same again, but I change something. I put less than or equal to 0. Stay in the same situation or we have solution? Stay in the same situation or we have solution?
Wouldn't it be all real numbers since it includes?
Exactly. She said all real number. All real number? No. No. Okay. I agree with you, Miss. See, you have that situation. Look, let me show you. Suppose X, I take advantage to analyze both. Okay. Look, I start for the easy part, greater than or equal to 0, all real number, yes. Less than 0, no solution. Just I complicate my life, less than 0 and greater than 0. She say all real number except 0. This is correct, but in this case, it's all real number, so it's from negative infinity, comma 0, a union 0, comma infinity, right? Because in 0, so this guy is always positive. Okay, we have solution except in 0. because 0 is 0 to the 4th power divided by 0 to the 2nd power plus 9. This is 0 over 9, que es 0, and 0 is no greater than 0. So you exclude inside the solution. So this is equivalent to say no 0. Okay, in interval notation is this way. And in this case, we have solution. Well, yes, it's interval, 2 interval. In this case, we have solution or no? What do you think? Stay no solution, or we have solution? We have solution or no? What do you think? I know it's confusing, but you need to use your common sense, imagination. Okay, this expression is always positive. At least this sign is stupid. And I saw that. But this sign equal, let me use another color, equal is not stupid. We have solution for that part, case at 0. No? So in this case, at x equals 0, we have solution. Do you see or no? No?
Yes, yes.
Okay. So to understand, remember. Let me erase that part. Remember. Sometimes it's confusing. This. Less than or equal to 0. To understand this, you break it down into pieces. One piece, que es a strict inequality, que es that part, and no or this piece, que es John's equation. Now, how do you know when it's on this or? Because you know what it is. Meaning of this sign is like that, is less than or equal to. Therefore, less than is this, equal to is this. Now, I know very well that this piece have no solution. I analyzed before. I don't want to repeat again this idea. However, this is easy. Equal is equation. And you know that rational equals 0 is because the responsibility is the top part is equal 0. Okay, this is equivalent to say x to the 4th power equals 0. Okay, by the way, is x equals 0. Yes, we have solution only one, x equals 0. Clear or confusing, no? A little bit, right? Okay. Let's do two more examples. To finish that. Do you see that I sent to you the review package?
Yes.
Yes.
And next video and next day, I resend again for the students that are missing today the review because I want to start as soon as possible. It's too long, no? We dedicate 2 or 3 lectures to cover everything to be ready for the test. Suppose this example. 2 over x minus 1 greater than 4 over x. Oh, look like easy. What should I do? I need help. What should I do? Cross multiplication.
Subtract.
Exactly. Very well. Why, Miss?
X. To make it equal to 0.
Exactly. Very well. After that. Ready? We have ready to create, to find critical value, partition, or not yet? Not yet, no?
We can factor.
We can factor or condensing this and this together in only one fraction. So this and this together in only one fraction. No, two fractions separate like that. No. A, B minus C, D. No, this is not good. I need something, 1 divided by something. So 1 rational pero compact en only one, no en 2 separated by negative and plus. Okay, so I need to do something. What should I do? Bueno, okay, wow. I need to copy again this. Well, let's do it. So important moment, super important moment is, she said, you copy that, you move this to the left, because I need to create right-hand side. Okay, entonces, least common denominator. What is the least common denominator in this case? What is the least common denominator? And between x minus 1 and x. It's both, no? Because they are different factors, no? Factor out x times x minus 1. You divide mentally, LCD divided by each denominator and multiply by corresponding numerator. So when you divide, it's obvious que stay alive x times 2 is 2x minus 4 times x minus 1. Everyone follow me or no?
Yes.
Yeah, one easy, super easy way to verify that the thing that we're doing is correct. You again do it backward to verify. You separate again. Suppose 2x divided by x minus 1 minus 4 x minus 1 divided by x over x minus 1. And you see that this guy is cancelled. And you see that this guy is cancelled. And stay 2 over x minus 1 minus 4 over x. And we come back at the beginning. But I don't want to do this, of course. It's only to double check it. Everyone follow me? Everyone understand the thing I am doing?
Yes.
Okay. Yeah. Okay, therefore, after that, what should I do? When it's easy, you distribute it and combine later. Is distributed here. 2x minus 4x plus 4, no? Divided by x minus 1 greater than 0. Entonces, if we combine later, 2 minus 4 is negative 2x plus 4 over x minus 1 greater than 0. You leave it like that, you can. However, no, I don't like. Because I can see two things. Number one, and the top is their common factor, que es 2. Y also, bueno, we can, entonces, you factor out, what do you think? You factor out 2 positive or 2 negative? Either way. Suppose que one student say, well, I factor out negative 2, professor. Okay. Then we have x minus 2, no? Because negative times negative is positive. Divided by x minus 1. Entonces now these two I can delete or no?
No.
No, she said no. Entonces I included this negative 2 in the, this is my final beautiful inequality to start the analysis or no? Or I need to do something extra? Tell me, guy. I know that this is confusing. But you need to understand the thinking you are doing. Suppose que this 2 is positive. We can delete? Or no? Delete like that, look. You can or no? Yes or no? Yes or no? Hey, what's going on? Are you sleeping? Come on, help me. Help me. Nobody.
I just don't know.
No?
You can turn it into a positive and then flip.
Exactly. Is the idea. She said convert to positive. How you convert to positive? Multiply both sides by -1 or divide by -2. Suppose you divide by -2 both sides. Suppose. In this step, you divide both sides by -1. Divide by -1. Let me use in symbolic way. I like this way. Divide by -2. Both sides. Now, si you divide by -2, es obvio que this -2 erase is x minus 2 over x times x minus 1. Y in the right hand side is 0, because 0 divided by something is 0. But the only thing you should do is reverse that. So actually, I delete this -2, pero be careful because it's negative, so you reverse the sign. And this is our inequality que you focus to solving. Got it? Wow, amazing. Look how many algebra of the manipulation at the beginning. This is the given inequality that nobody can solve it. And another stupid guy tried to solve it using cross multiplication. It's impossible. Doing no, it's crazy. And this is a new one. What should I do now? What should I do now? What should I do now? Here, at that moment, when I have this situation, let me using yellow color to highlight this because I love you. This inequality. What should I do? What should I do? What should I do? What should I do? Critical value, ¿no?
Yes.
Ajá, critical value es obvio que es 2, es 0 y es 1. Correct? You see mentally here? Partition now. Uh-huh. 0, 1, and 2. 3 partition, 4 interval. Select testing point maybe -1. Positive half, 1.5, and 3. You can select either, but I prefer close to the critical value. Okay, now ready to create table. -1, half, 1.5, and 3. And the factor is x minus 2. It doesn't matter the order. You copy in the order. X and x minus. And 12. It's so obvious that this column have exactly the same testing point. It's a negative, positive, positive, positive. Because do not subtracting anything directly, plugging it. This is negative because -1 minus 2. This is negative because of -1 minus 1. Yeah, and -2. Entonces 3 negative is negative. 1/2 is negative. 1/2 is also negative. 2 negative positive. 1.5 is negative. 1.5 is positive here. We have 1 negative and negative. And 3 is positive and positive. It's positive. We come back at the beginning. Look at that. My inequality is less than 0. That means the true guy is a negative. Negative is here and negative is here. Down the testing point que pass is including -1. incluye 3. What about the endpoint? This continue forever in that direction. It's continue forever in that direction. And what about the 0 and 2? Well, no, never include because our inequality is a strict inequality. No equal, no equal. So when there's no equal, always is parentheses, never a bracket. When it's equal, only is bracket the 0 of the top part. But in this case, no, it's easy. It's something like that. Therefore, my final answer is negative infinity, comma 0, parenthesis, union, 2, comma, infinity. Okay. Any question? You follow me? Okay, the answer, let me copy this answer. This answer is from negative infinity, comma 0, union, to comma infinity. Super. Okay. Let's do one more. Let's do one more. 2 more. Okay. Everyone follow me so far?
Yes.
Okay. Let me complicate a little bit. Look. Suppose 3 minus x, 4x minus 1 raised to the 4th power divided by x plus 2 squared. And this is less than or equal to 0. What do you think? You can delete totally or partially. Delete or no? Come on, help me. You delete some factor or no? You delete some factor or no?
The 4x plus 1.
Okay. The answer again I want is yes or no. Delete or no?
Yes.
Okay, yes. I agree with you. And my next question is partial or totally? Partial or totally?
Partial.
Why? See, I say que partial is, okay, totally is when you have equal sign. And partial is when you have no equal sign. In this case, we have equal sign, no?
So totally.
Totally. Entonces, now, entonces I convert this complicated problem in this problem. 3 minus x less than or equal to 0. But be careful. Bueno, okay. This is this. Entonces, I solve this inequality. Maybe I move this minus 3 divided by negative 1 divided by negative 1. Entonces, x greater than or equal 3. However, this is the solution of the, remember, okay, the solution for the inequality part is less than 0 is less than 0, is less than 0. However, what happened in the equal sign? Equal sign is the critical value of the top, que is 3 minus x and 4x minus 1 to the 4 power equal to 0. Entonces you separate two pieces. 3 minus x is equal to 0. Wow, it's easy. It's x equal 3, exactly the same. So this 3 is all logical, include this 3 and the endpoint. But we include another, que es 4x minus 1 equal to 0, que es 4x equal 1 divided by 4 is x equal 1 over 4, 1 quarter. Entonces, bueno, professor, but what is the solution? I don't understand. Well, let me try to understand. The solution is, this is all real number line. This is 0. This is 1. This is 2. This is 3. The interval is from 3 to infinity. That's correct. This is this part is also that part. Include 3. Bracket. However, 1 quarter is located here. And between 0 and 1, 1 quarter is a half, 1 quarter here. It's also solution. Because one isolated point. Because 1 over 4, if you plug in here, 1 over 4 is 0. And 0 is equal to 0. At least that part is true. So you totally delete. But under the consideration, be careful that you try to include inside the solution the 0 of the numerator. That's what I find an answer. How you write that? Well, you write like that. Either way, you write answer. Answer is bracket 3, comma infinite, union, 1 quarter, separate like a 1 isolate point. Entonces, when there's 1 isolate point, you denote using curly bracket. Very, very, very similar. This is union to the solution for the equation. Remember that when you solve the equation or inequality, que is different point isolated. Suppose that the equation, one equation hypothetically, the solution is 1, 2, 3, 1, 2, 3. You listing like that. Solution set is 1, 2, 3. So exactly the same. This isolated point you listing like that, and you connecting both pieces of the solution. This is confusing, eh? Clear or no? Okay, so now, next time, we start doing the review. Review is we go over again at the beginning. The beginning, what is the beginning? System of equation, blah, 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 rational function, etc. No? Polynomial, rational function, etc. And our part, okay, is the inequality. Okay? Beautiful. Okay. Bueno, guys. Thank you so much. Bye-bye. Have a nice day.
Have a good one.
Okay.
Have a good day.